Good day from ChemHelp ASAP. In this video we're going to talk about structural isomers. Okay, on the screen we have a table which we saw in another video, and we have two molecular formulas written, and they are the same molecular formula, but this demonstrates kind of a weakness in molecular formula. Molecular formula is great for communicating how many of the different types of atoms you have in a molecule, but it doesn't tell how they're put together. And so here we're going to have a case where we have two molecules that have the same molecular formula and yet different molecular structures. And we can see that in the middle column. Now we've written out the condensed molecular structure for these two molecules, propanol and isopropanol. And we can see that they're different. They're different despite the fact that the molecular formula is the same. Now, this top condensed molecular formula can actually be even more condensed. So, since we have repeating CH2 units, sometimes people will say, let's smash those together, and with parentheses, say that there are two CH2 groups, and then we get to the end of the molecule with an OH. The bottom condensed molecular structure is condensed about as far as we can. So let's read these condensed molecular structures and show them as Lewis structures. So for the first structure, the top structure, I'm just going to start at the end. We have a carbon which is attached to three hydrogens. We need a fourth bond for that carbon, so we'll look to the next carbon to satisfy that need. And that carbon in turn has two hydrogens, and it needs a fourth bond, so we'll go to the next CH2 group, our third carbon, which has two hydrogens, and then finally, coming off the end, the last bond to our third carbon is to an oxygen, which has an H on it. Now, this oxygen is neutral, and neutral oxygens that have two bonds will have two lone pairs to satisfy that octet rule for the oxygen. So this is one structure. This is the Lewis structure for propanol. Now let's take the other form. We have in this one we have two. We're not going to start with these CH3 groups because we can see that there are two of them and they're both attached to one carbon. So let's get that one carbon written in, and we will have that carbon. In turn, we will then add the two CH3 groups to that central carbon. Now, our central carbon only has two bonds. It needs two more bonds. We can see from the condensed structure there is a hydrogen on that carbon, so we'll put that in. And then we have the oxygen coming off, so the oxygen with its hydrogen. And then again, neutral oxygen, it's going to have two lone pairs to complete its octet, and that's that structure. So these are isomeric structures. They're we call these structural isomers. Sometimes they're called constitutional isomers. These have different structure despite having the exact same molecular formula. As we get into larger and larger structures with larger and more atoms in their molecular formula, we're going to find that there are a lot of different isomers that we can draw for each of those structures. And so we need to be able to distinguish them some way besides the molecular formula, but by using other means like condensed molecular structure or Lewis dot structures.